Good morning, everyone. I want to welcome you to my lecture today. Of course, today we're going to continue from conditional probability and Bayes rule. So that's why I call this part two. In the outline today, I'm going to walk you through conditional probability, independent event, the law of total probability, and Bayes rule. And of course, I'm going to give you a real life application of Bayes rule. So, but I'm going to first start with some work examples. Okay, take a look at what I have here. This is a survey that was conducted, and of course, you have two categorical variables. The categorical variables, you got gender and responses. Of course, the gender has two levels, and the response actually have two levels. And of course, this is a survey that was conducted on 100 people. You know, they're trying to investigate their thoughts, their perception, whether women in the armed forces should be allowed to participate in combat. And this is the result of the analysis that was conducted. Now, based on this now, we want to find the probability that the answer yes, given that they were female. Whenever you see, I needed to pay attention to the underlying word given. Whenever that word is given, then the idea of a conditional probability should comes in. So conditional probability, we're trying to we want to figure out the probability of an event given that there a particular event has occurred. So what we want to figure out here, you want to find the probability that the answer yes, and given that they were female. Now, how are we going to interpret that mathematically? Okay, I needed to pay attention to that. Yes, I'm actually using Y for yes, and I'm using F for female. Okay, we're allowed to use our letter. Okay, so it means I want to find the probability of Y given F. This shouldn't be interpreted as this. So this and this, okay, they are not the same. Okay, here yes is conditioned on female, and here female is conditioned on yes. The two are not the same. So if you take a look at this in the picture, find the probability that they answered yes, given that they were female. So it means the event of female will have to come first. Does that make sense? Now, if you now want to go by what you learned, okay, by the formula for conditional probability, now this is going to be the ratio of the joint to the probability of the event that occur first. Now, if I want to rewrite the same for this, it's actually, this is going to be F and Y divided by P of Y. So this is different. So this is F and Y divided by P of F. You can see, in definition, the two of them are not the same. Now, based on what you see right now, so you're actually going to focus yourself. What is that? Y and F. Yes and female. This is yes, and this is female. Okay, that probability is actually going to be 8 divided by 100 That is for the numerator. Okay. Now that is the if you now want to get probability of F, now the probability of F will now be cardinality of F. So how many female do we have? 50 divided by 100. And that was why you got this initially. Can you see that? It's over 100 false. So this guy is this guy, and this guy is this guy. By the time you simplify, you're actually going to have it over 50 or 4 over 25 or 0.16. So probability result can be left in terms of fraction, and make sure you simplify, or you can leave it in decimal. We can also leave it in percentages. Now I'm going to move to another one. Here, find the probability that the answer yes. Okay, given that, that's what we just found. Now, another one, find the probability that they were male, given that they answered no. Okay, you see that? You see the formula? Okay, they answered no, that they were male. They were male, given. The moment you see given, okay, then I answered no occur first. And the answer no is what you're gonna see here. The one here is the current event of interest. Which is conditioned on what has occurred, what occurred first. Now, if you similarly you go the same way, you're actually gonna have that, which means you need to first figure out the probability of male and no. The probability of male and no is actually going to be 18 over 100. Okay, if you find the denominator, so that will be 18 over 100. The probability of no will be 60 over 100. And at the end of the day, when you simplify, that's what you're going to have. Is there any question moving forward? Oh, good, right? Now, I'm going to go to the next one, independent events. Now, I told you the other time, events are independent if they can occur together. Okay, they are independent, they can occur together. And what is the implication? So I'm actually going to show you, particularly for two events. If A and B are independent, the probability of them occurring together is just going to be the products of the respective one. Now, if I have three events, A1 intersection A2 intersection A3, so it's actually going to be A1 A2 and A3. Okay, now this is a situation where we believe the events are independent. Now I'm going to walk you through that now. So now if you take a look at what you are seeing right now, particularly we're taking a look at this guy. Okay, now I want to talk about